Hello mariners, I am making the third video on ballast water management. This is on D-2 standard. This is the third part of the series and in which I am covering the treatment methods. In the treatment methods, the first part, the solid liquid separation, how is it carried out, will be covered. The Ballast Water Management Convention, which has been updated, it is covering regulation D-1, which is Ballast Water Exchange Standard. You can see that in my previous video. Regulation D-2, which now we are covering partly in this video. D3 is approval requirement for ballast water management systems. This is more of an academic subject but used for the surveyors. Regulation D4 prototype ballast water treatment technologies again been approved by the IMO and more of an academic subjects. And regulation D5 review of standard by the organization is we are talking about what the IMO is doing it. We are coming to the main topic. We are talking about regulation D2, the ballast water treatment performance standard. Okay. Now this D2 came into force on 13th October 2019 and it came for the new building ships and all other ships. They had been told that you have to start following the D2 standards, which should be finally implemented by the date which is shown here is 8 September 2024. The new ships which are there have to be done. Any ship built after 13th October 2019 has to comply with the D2 standard, and all ships have to comply by 8 September 2024. In other words, they do not have to carry out exchange. They require a ballast water treatment plant to be retrofitted. The existing ships need to be retrofitted and they have to be made operational, certified by the class, and it has to be used. So let us look into the ballast water management requirement as per D2. This in the next slide, what you see is that how exactly in the chronological order it has gone from D1 to D2 and what are the dates and when the new ships which have to start complying and all ships which are already been complying, which is coming on 8 September 2024. Now, what does the D2 standard say? The D2 standard covers all approved ballast water treatment system. It goes much into elaborate of it. We are going to cover the one which are commonly used water ballast system and presently been retrofitted or fitted on board, and it also specifies the maximum amount of viable organism that can be discharged into sea. You can look into my previous videos, Ballast Water Management Part 1 and Part 2, where we have said that these viable organisms which are going from one part of the ocean and seas to another part are creating a great havoc. So, the ships in international traffic must remove or neutralize aquatic organism and pathogens, which is required. This is required to be doing on all existing ships by 8 September 2024. The next what is coming is that they require to have a approved ballast water management system. The approved has to be done by a classification society or a standard body as accepted by the flag state. This code establishes how ballast water management system uses to achieve D2 standard. How this D2 is also telling you how it has to be assessed and approved. Okay, various approval systems are available in the market, including using physical method and those using active substances. We are going much into the detail in that. In summary, D2 standards ensure that aquatic organisms and pathogens are removed or rendered harmless before ballast water is released from one ocean to another ocean, thereby preventing the spread of invasive species and potential harm to marine ecosystem. When we speak about the ballast water management system approval, also every ship is supposed to have a ballast water management certificate. A copy of the certificate is shown here. Now, if you look more into the detail, the ships are required to have D2, not D1. This is an old certificate which is given to a ship and a copy is given to you. The next is what is the standard? The standard as per ballast water treatment is plankton is 50 micro ohm in minimum diameter, and how much is there? Then plankton is 10 to 50 micrometer. Then we have toxicogenic Vibrio cholera. Then the next one which is there is Escherichia coli and intestinal enterococci. The pronunciation is little different for a layman, especially the one who is not into medicine. And these, they have given the regulation how much is accepted, and they say that these regulation D2 is giving a standard which I have forwarded to you. Now the ballast water treatment system must have a type approval certificate as per the IMO guidelines, and this type approval certificate has to be kept on board. It remains with the master. This is as per MEPC, Marine Environmental Pollution Committee 174 into bracket 58, and further MEPC 125/53. Both the resolutions have to be, they give the standard how the ballast water management system will be kept. In the bottom which you see are what we are talking about, the organism, the type of organism which the ballast water management has to remove so they do not create a havoc on board. Now let us have an overall view of the present ballast water management system. The ballast water management system is broadly divided into two methods. Number one is the ballast water exchange, which is D1, and we have discussed a lot about it. Sequential flow through and dilution, you can refer to the old one, and they have already become obsolete, so we will not go much into the detail of it. Now the next thing what is coming up is the ballast water treatment as per D2, and when we are talking D2, there are three methods. Number one is the mechanical method, second is the physical method, and third is the chemical method. In this video, we are covering only the mechanical method. The mechanical method is filtration, magnetic separation, and coagulation which is coming up. But how exactly it is being done, we are going to talk on that. We also have a method called the hydrocyclone which is coming up, which is in the part of the mechanical one. Let us look more into it. The other one, chemical method, will be covered in the next video. Now, when we talk about the recording process, that is coming as per how the records have to be done. So, similar to oil record book, we have a ballast record book. We will make a separate video on that, giving all the detail how it has to be filled up and how the record has to be maintained. Third is the training and education. In training and education, we will be discussing that the equipment on board, how the training has to be done by manuals and videos, and it also either on the ship or ashore, that is covering here. Sediment management, either during the filtration, when the sediments are coming, how you are removing the sediments. Also, in case you are getting silt in the tank, we have to remove it regularly. Next is, in case we are unable to have the ballast water treatment plant, then how are we going to isolate it, or how can we send it to the reception facilities ashore, and the tank cleaning, the quality of tank cleaning which needs to be carried out. The complete overview is there, but in this video we are only covering the ballast water treatment, the filtration part, and then the further will be covered in the next video. Here what you see is the ballast water which is taken from the sea, which is coming in the ballast pump and going in the filtration system, and it is getting filtered, and further it is going through the treatment system and then going to the ballast tanks. The backwash is again sent overboard, which is shown in green color. So only the filtration system we are going to cover here. This is a simple diagram which is showing how the ballasting the treatment is carried out on board in a simple method. The other method is when we are doing the deballasting, when it is coming from the ballast tank, it is directly going in the ballast pump. From there it is directly going to the treatment system, and there it is going overboard. Normally the filtration is avoided here, which is seen very clearly. The next diagram exactly is showing where exactly are the ballast tanks on board. Normally the ballast water treatment system either is an engine room, in case it is a tanker, it is also fitted in the pump room. There are different regulations in case you are fitting the ballast water treatment plant in a dangerous area. You have different standards. In case it is in a safe zone, there are different standards. They are mentioned in the IMO regulation. We are not going much into the detail of that. Okay. Here what you see in both the pictures now is the simple filtration method what we had seen earlier. Now D2 standards which are there, how are we going to do filtration and treatment method? Number one is hydrocyclone, which is physical separation of solid and liquid, which is done. Number one is the hydrocyclone surface. Second is the surface filtration. Third is chemical enhancement by coagulation and flocculation, which we are going about. In the next video, we will be talking about disinfection, how the disinfection needs to be carried out. The chemical treatment, the physical treatment. In chemical treatment, how the chlorination is done, the electrochlorination, the ozonation, peractic acid, C-clean and chlorine dioxide are used. In physical treatment, where we are doing the disinfection, we are using ultraviolet radiation, deoxynation, gas injection, ultrasonic treatment and cavitation. The residual control is chemical reduction by sulfite and bisulfite, physical enhancement, ultrasonic treatment and cavitation. This is normally the process which is done. Now let us look at the overview how the treatment or D2 is being carried out. The first step is the filtration, which we are talking in this one. The right water filter serves practical and economic purpose in the ballast water treatment system. Okay, we will be discussing that, which is the filtration treatment. After the filtration, where all the solids are being removed and the water is being treated, the solids are completely removed. The next process is the water is getting treated. This is step 2. You are either doing chemical disinfection, ultraviolet treatment, heat treatment or ultrasonic treatment, or deoxygenation. Any of them, this is there. Now, once the complete treatment is done, you are further putting the water in the ballast tank and they are ready to be stored. Solid liquid separation. Now let's come down to the first process of filtration. This is solid liquid separation. Now, two generic type of process are used in ballast water: solid liquid separation and disinfection. Solid liquid separation is simply the separation of the suspended solid material, including large suspended microorganism, from the ballast water either by sedimentation, allowing the solid to settle out in virtue of their own weight, or by surface filtration, removed by straining, or by virtue of pores in the filtration material being small than the size of the particle of organism. All solid liquid separation processes produce a waste stream containing the suspended solids. This waste stream comprises the backwash water from filtering operations or underflow from hydrocyclone separation. Let us look into the processes in a little detail. This waste stream require appropriate management, and during ballasting they can safely be discharged at the point where they are taken up. We are removing the solids then and there at the load port. You are in a river port. There is a lot of mud in the river. You are taking the ballast. At the same time, you are removing the ballast by the first process, which is solid liquid separation, which is getting carried out. On deballasting, the solid liquid separation operation is generally bypassed, which I had shown you in the video. The solid liquid separation, basically three methods are used. Number one is filtration. Okay, it is generally using disc or fixed screen with automatic backwashing. This is effective for large particles and organisms. It maintains flow with minimum pressure drop, requires backwash. Whenever filters are there, the filters are getting choked with lot of mud. You require to carry out a backwash. With the backwash, the complete screen is getting cleaned. The lower membrane permeably means surface filtration of small microorganism is not practical. Mesh size are proportional to the size of organism filtered. That is, large organisms such as plankton require mesh between 10 to 15 microohm. Okay. Hydrocyclone, high velocity centrifugal rotation of water to separate particles. We have hydrocyclone is nowadays commonly used for water treatment, and normally all the larger particles are falling down. It is using the principle of centrifugal rotation Okay, alternate to filtration and can be more effective. Hydrocyclone is more effective, and lot of ships are using hydrocyclone. It is easy to clean, and large particles are going out, they are going back to the sea. Effective for large particles. Effectiveness depends on density of the particle and surrounding water, particle size, speed and rotation and time. Coagulation. The coagulation means optimal pretreatment before separation of the aggregate particles to increase their size. The silting, the mud which is there, are passing through the filter because the size is very small. We need to increase the size of the particle so that they get stuck. For that, there is a method called coagulation. Okay. Once the coagulation is done, then we are using flocation, which is by many methods, so that they settle down in the bottom fast and we are removing from the bottom. Okay, but for this method we require an additional tank, okay, to store water which has been treated due to long residual time for the process to be effective. Have a look at this. We have the filtration, the screen, fixed or movable or disc are used for effectively remove suspended solid particles from the ballast water with automatic backwashing. These are extremely environmental friendly as they do not require usage of toxic chemical in the ballast water. Screen filtration is effective for removing suspended solid particles of large size but not very handy in removing particles and organisms of smaller size. It has been noticed that through several screens highly effective in removing majority of the suspended solid particles and organisms from ballast water, they alone are not sufficient to treat the ballast water according to the IMO standards. Screens are used, but in addition to them, either you have one of the system, either hydrocyclone or coagulation is also used. Here what you see is the filtration process, and we have the filters, how the filters are being used. Another photo is showing once it is completely boxed up. Once the filtration is opened, you can see the filter screen. This is cleaning the strainer, and this is one of the filters which is being used. The next system what is coming is the hydrocyclone. The hydrocyclone is the effective equipment for separating suspended solids from the ballast water. Here in the photo on the right hand side, what you see is that the dirty fluid is going inside, and like a whirlwind it is going down. While it is going down, what you see that the solid particles are slowly and steadily coming in the center, and while they are coming in the center, they are falling down. The liquid which is clear, which has got the liquid which doesn't have any solid particles, much of solid particles left, are coming up and they are taken out. Okay, so this is the simple principle which is used for hydrocyclone. High velocity centrifugal force is used to rotate the water to separate solid and doesn't have a moving part. It is easy to install, operate and maintain on board ship. Okay. It has been found that as the operation of hydrocyclone heavily depends on the mass and density of the particle, they are not successful in removing small organism from the ballast water. In simple word, either you have the filtration or the hydrocyclone, but another third method is required which we are coming into, and that is coagulation and flocculation. Coagulation is the process of adding chemicals to the water, causing them to bind together and form flocks. How does the coagulation work? The coagulation process involving we have to add chemicals to the water to encourage suspended particles to clump together. They start coming together. This chemical process neutralizes the particles charge, which is negative charge, causing them to form microflux. When enough coagulant is added, there is a defined difference between the clumped microflux and the clear water surrounding them. It is important not to add too much coagulant, which may have the opposite effect and cause the suspended particles to repel one another. After the coagulation, there is another process which is known as flocculation. In flocculation, the process of adding floccuant to water, which further encourages floc formation and increases the floc size, make them easier to remove the clumps of the particle sink at the bottom of the treatment chamber, where they can be removed from the water at the later stage. Coagulation is removing the electric charge, making the particle to come together. Flocculation is further going above and it is making a big clump, and it is also settling in the bottom. The agent that encourages the particles to clump together in flocculation and making them easy to remove from the water are floccuants. During flocculation, microflocks grow larger, forming suspended pin flocks which are visible to the eye. This pin flocks produces even larger flocks called macroflocks, which then they collide during the process. At this stage, the water treatment polymers may be added to strengthen the floc and increase its settling weight, making it easier to remove. Eventually, the floc will achieve optimum strength and size and are ready to be separated from water. The stage that follows the process is usually sedimentation. Now, mind you, how much of chemical dosing has to be done will be mentioned in the manual, and also depending on what is the quality of ballast which you are taking. Okay. And then the next what they have said is how they are doing the coagulation and flocculation. The coagulant is inorganic or organic. Mud, sand, etc. is coming. Then we have Pinkton, bacteria and viruses. Coagulation is putting them down. We are using magnetic separation, and this magnetic floc which is there is cleaning up, and you are getting a treated water. This is all right now for the physical separation. We are coming furthermore to the chemical separation. The new regulations which are coming up are quite interesting, and all mariners, I expect you, in case of any query, please write a mention, and I am looking forward for any questions which are relevant to the topic, which are not understood by you. Please let me know. Kindly subscribe to my channel, and I am looking forward to make further more videos. Thank you very much. Bye.